Hi, so in this short video we are going to take a look at power and the formulas that are used to calculate power in circuits, and when we're talking about domestic energy, how much power a particular appliance uses. So, power, what is it? Well, power is the amount of joules of energy that are transferred to an appliance every second. So this line just means per, it's the divide line. So power equals joules per second. Joules is a measure of energy. So we're saying how many joules are transferred every second. So if you have a 40 watt bulb, so we've got a bulb here, oh, that's a rubbish bulb, let me draw that again. Hang on. We've got a light bulb here, and if we say that this is a 40 watt bulb, what we're saying is there are 40 joules of energy being transferred from electricity to the bulb every second. And that's all power is, it's just joules per second. So W is watts. So power is measured in watts. And all the watt is, W, all the watt is joules per second. So how do we calculate power? Well, there are a couple of ways to calculate power, and these will depend on the information that you're given in any questions. The first one we're going to take a look at is power equals potential difference times current. So power equals PD times current. Okay, so if you are given a circuit, something like this, and you've got a bulb here, and you've got an ammeter here and a voltmeter here. So an ammeter in series, voltmeter in parallel, and we say that the volts that are going through the bulb are 3 volts, and we're getting a current of 1.5 amps. We can now put P equals V times I. So P, power, equals potential difference of 3 volts times 1.5 amps. So P would equal 4.5 watts. And that first equation is really that easy. It's just literally voltage times current, and that equals the power. The next equation's a little bit trickier, but not really that tricky, and that is P, power, equals current squared times resistance. So in this video we're looking for power, current, and resistance. So if you have a question where these are involved, power in watts, current in amps, or resistance in ohms. So in this example we've got a lamp here with a resistance of 3 ohms. We've got an ammeter which, let's say, has got a current of 2 amps. So we've put that into our formula. Power equals current squared times resistance. So power equals the current squared, so that's 2 squared. So that's 2 squared times the resistance, which is 3 ohms. 3 ohms. So P equals 2 squared, 2 times by 2, 2 times by itself, so 2 squared is 4, times the resistance of 3, so the power equals 12 watts. That means there's 12 joules per second flowing through the bulb. So it's a 12 watt bulb. So when faced with questions that ask you about power, make sure you look at the different components that you've got in the circuit. So this first one, you can see that you've been given information on volts and current, so this is the formula that you need. The next one, you can see that you've been given information about resistance and current, so this is the formula that you need. This component here, that could quite easily be an actual resistor itself. So you could get a circuit like that where you're asked to use that. The component itself isn't particularly important, it's the numbers that you get. So that's how you determine which formula you're going to use for calculating power. Keep your eyes peeled for practice questions. As I say, the maths isn't particularly difficult in this. In the first one it's potential difference times current, and the next one it's just current squared times resistance, and current squared, whatever the number is, you just square it, and you can do that on your calculator. It's the number times by itself. So if the current was 4.5, well, it'd just be 4.5 times 4.5, whatever the number is squared. But I know you know how to square. So keep your eyes peeled for practice questions and walkthrough videos, and that's as simple as power is.